In this video, we'll discuss the composition of an electromagnetic wave. Now, the word electromagnetic has two distinct parts, doesn't it? First, here in red is electro. That's going to mean there's something electric in an EM wave. Second part is magnetic. That means there's something magnetic in the EM wave. Something electric and something magnetic in an EM wave. Before we go look at those two things, you remember these two kinds of mechanical waves, don't you? Remember these a transverse wave, back and forth across the center line. There's your center line. Back and forth like this, a transverse wave. Then we had longitudinal that had compressions that traveled down the length of the medium, didn't we? Alright, so here's a picture of the internal structure of an electromagnetic wave. It really has two transverse waves, doesn't it? First, electromagnetic. We have an electric field, and it's represented by a wave, like this, the red one. A transverse wave, right? Then we have magnetic, which is a second transverse wave. It comes out like this. Can you see that they're perpendicular to each other? Right there? Yeah, they're perpendicular to each other, and they're traveling this way. So an EM wave really has two transverse waves in it, perpendicular to each other. Let me read this. If you're asked for the type of a wave for an EM wave, say it's a transverse wave, even though it's really two transverse waves. Now we know there are two transverse waves here, and we can see that. But if you had a multiple choice question that said, is it transverse or is it longitudinal, or is it sound, something like that, you definitely should answer transverse, even though you know it's really two transverse waves. And that's about it for the composition of an EM wave. Your video code here is really two waves. Really two waves. Bye.